Okay, if you haven't already set up your Cornell notes, here's the topic and the essential question for today. So topic section 2.1. So I did these a little out of order just because I knew I was going to be gone today, and so I wanted to make sure that it was an easier section to understand while I'm gone. So if you need to pause any time throughout these notes, please do. I won't always remind you, but if you're copying something down, go ahead and pause, and then you can unpause it when you're ready to go again as a class. All right, so only one main idea today, and it's vocabulary. And we have about 3 vocabulary terms, and then we'll do 2 examples, and that'll be about it for today. Section 2.2 for sure is the longest section in this chapter, a lot of vocabulary. Okay, first vocabulary term is a conjecture. So a conjecture is an unproven statement based on observations. So we're going to make conjectures when we observe something going on, and in this case we'll be looking at different patterns or sequences and kind of see what the next terms would be, for instance. So a conjecture is an unproven statement based on observations. Our next vocabulary term is inductive reasoning, and that was mentioned in the, both of these were mentioned in the essential question. So inductive reasoning is when you make a conjecture based on observations. So the act of you looking for a pattern and then making a conjecture, that whole process is using inductive reasoning. So you're observing what's going on, and then you make a statement based on those observations, or make that conjecture based on those observations. And so I put in here the process there of looking for a pattern. That's inductive reasoning. And then our last one is counterexample. A counterexample is an example that disproves a conjecture. And our counterexample can come in the form of a picture, or it can come in the form of some value for a variable, whatever the problem is calling for. Okay. All right, so example 1, if you go ahead and pause this so that you can copy this down. I didn't print these out because these are pretty simple examples, not a whole lot of complicated pictures or anything. So go ahead and pause and copy this into your skinny column on the left, and then we'll get working on them. Okay, example 1. So part A, and try not to write over here. Remember, we try to keep this clean and just do all our work over here so that you can cover up this note side eventually, getting ready for the test, and just see the problems and be able to rework them out. So our first one is 2, 6, 8, 18, 54, and it goes on. Okay, so we want the next 2 terms, so 2 blanks here, and then write a conjecture that describes the pattern. And I'll let you know here, the conjecture is a little bit of a formula here. Basically, you have to have some things in it. Okay, so what do you guys see going on here? What's this pattern going to be? I'm hoping that you say we're multiplying by 3. That's what's consistently happening each time. So then we need to go ahead and multiply by 3 times 54 to get the next term. And that should be 162. And then do it again. 162 times 3. And you should get 486. So there's the first part. You've got your next 2 terms. Okay? Now the next part is we need to write a conjecture that describes what's going on. And there's 2 pieces that you have to have in it. You have to say something about what you're doing to the previous term to get the next term. Okay, so here you can't just write multiply by 3. Well, what am I multiplying by 3? What is that going to give me? So you have to be specific when you write the conjecture. So you would have to say something like multiply the previous term or previous number, however you want to write that. I always use the word term, but these are numbers, so you can certainly use that. So multiply the previous term by 3 to get the next term. Okay, So you have to have, what I was saying earlier is you have to have previous term in there and next term somehow, and then whatever it is that you're doing. So here we multiply the previous term by 3 to get the next term. So if you want to get your full point for the conjecture, it needs to be precise. You can't just write multiply by 3 because you're not explaining, well, what am I multiplying by 3 and what is that going to give me? So multiply the previous term by 3 to get the next term. Okay, so these problems would be worth 2 points. 2 points, or 1 point for both of these, so halves each, and then 1 whole point for your conjecture. Okay? All right, now let's look at B. So 7, 9, 13, 19, 27. So take a minute, go ahead and pause and see if you can figure out what the pattern is, what's going on here. Okay, so you probably noticed that you're not multiplying by a single thing, like a single number like we were earlier. So then that just leaves us to adding and subtracting. We're also not dividing. Hopefully you saw that it's getting bigger, it's not getting smaller, so we're not dividing. So then that leaves addition and subtraction. It'll have to be some sort of addition because we are getting bigger. So here it would be plus 2, here it would be plus 4, plus 6, plus 8. And so then to get the next term, we'd have to plus 10 because we're adding consecutive even numbers here to the previous terms. And so then if you add 10 there, you should get 37. And then you'd have to add the next even number, which is 12. So 37 plus 12 gives you 49. Okay, so those are your 2 terms that you get. Now we have to write the conjecture. And again, you have to say that previous term and next term in there. So you would say something like add the next consecutive even number, that's how you would say this, to the previous term to get the next term. And you can kind of change up the order of this. So you can say maybe start it out by saying to get the next term, add the previous term by the next consecutive even number. So you can somehow take this and make it in a different order if you wanted to. Again, what I'm looking for is the previous term, next term, and then on this one, the add the next consecutive even number. That's how you say this. If it was just adding plus 1, plus 2, plus 3, plus 4, it was just going in order, then it would just say add the next consecutive number. You would get rid of the even part. Or if it said plus 1, plus 3, plus 5, plus 7, plus 9, you're adding the next consecutive odd number. So that's how you say that. Okay? So the act of what we just did, so when we did part A, we looked for a pattern, predicted the next 2 terms, and came up with a conjecture that describes the pattern. That whole process that we performed on part A was inductive reasoning. You look for a pattern, maybe you have to predict what's going to happen next, and then you come up with a conjecture based on what you observed. So same thing here. We looked for a pattern, came up, predicted the next couple of terms, and then made a conjecture that described it. All of that process for part B was inductive reasoning. Okay? All right. Example 2. So go ahead and pause it and copy down example 2. Again, it's not too much. Save a little bit of paper from gluing stuff in. So go ahead and copy that down. Okay, so example 2. So the directions here say decide whether the statement is true or false. If it is false, give a counterexample. Okay? So part A, supplementary angles are always adjacent. Okay, so you got to remember back, chapter 1, supplementary angles, 2 angles that add up to 180 degrees. And this statement is saying that those always have to be adjacent, meaning adjacent angles. So remember, adjacent angles had to share a vertex, share a side, and couldn't overlap each other. So do all supplementary angle pairs have to be adjacent, true or false? I'm hoping that you're thinking false, because it is false. And so then we're going to draw a counterexample this time. So supplementary angles, so I need to draw two supplementary angles, or two angles that are supplementary. This is my favorite, I guess. I used it earlier on one of your problems on your homework. So angle A and angle B, those are supplementary, but they are not adjacent. They don't share a vertex, they don't share side, and they would overlap eventually if you extend those out. But anyway, it doesn't matter. They're just not adjacent. So that's an example, a counterexample, and I used a picture to help with that. Okay? All right, now let's look at part B. So all prime numbers are odd. Well, first you have to remember what a prime number is. So a prime number, the definition says it's any number that is divisible by 1 and itself only. Okay? So any number that is divisible by 1 and itself. So for instance, 7 is a prime number because it's only divisible by the number 1 and the number 7 itself. Okay? So think about this one. So decide if this one is true or false. So all prime numbers are odd. I'm going to tell you this is false. So what would my counterexample be? What is the one prime number that is not odd, which is even? 2. 2 is a prime number. If you were to list the prime numbers, it starts with 2. Now, so I always get people asking me, well, isn't 1 a prime number? No, 1 is not, because it's in the definition of a prime number. So it is not a prime number. So if you were to list the prime numbers, and then you could keep going, 2 is the very first one. This is even, but it is prime because it's divisible by 1 and 2 itself only. So this was a false statement. 2 is prime, but not odd. So that's why this proves that it's false. Okay? All right. That concludes notes for today. So right now, remember your first repetition within first 10 minutes of learning something, you guys need to highlight and circle. And now that we're in chapter 2, I'm not going to tell you what you should be highlighting and circling. So highlight main ideas and circle key terms. Then remember, tonight as part of your homework, you need to answer the essential question. How do you use inductive reasoning to write a conjecture? You need to answer that. And I'll be checking that tomorrow along with your book assignment that is listed on your tracking sheet. So that's the one that's on pages 75 through 76. And the answer key will be on Brightspace so that you can check your answers. But you do need to use your time in class right now to do this. And if you finish, then you can use the class time to check the answer key here in class, get it from the sub. And then that'll just be one less thing you have to do tonight, and then you could just write your summary. Okay? All right.